Hello there, I'm Dumsane. Welcome to this lesson on exponents. Today we are going to revise prime factorization. We'll need this for the next lesson, which deals with fractional exponents. By the end of this lesson, you should be able to define a prime number, identify prime numbers, and write numbers as products of prime numbers. What is a prime number? A prime number is a number that has only two different factors, namely 1 and the number itself. Now, how can we find out if a number is prime or not? You only have to factorize it. Is 12 a prime number? You have to ask yourself, which numbers can multiply to give you 12? Can you answer this? Let's have a look. 3 times 4 will give us 12. 2 times 6 will give us 12. 1 times 12 will give us 12. How many factors does 12 have? Or in other words, how many different numbers can divide into 12? Let's see. 1 can divide into 12. 2 can divide into 12. 3 can divide into 12. 4 also divides into 12. 6 can divide into 12. And 12 can divide into 12. So how many factors do we have? 1, 2, 3, 4, 5, 6 factors. We saw that 12 has 6 factors. That means 12 is not a prime number. What about 15? 1 can divide into 15. 3 can divide into 15. 5 divides into 15. And 15 divides into 15. 15 is not a prime number because it has 4 different factors. 1, 3, 5, and 15. What about 11? Let's see. 1 can divide into 11, and 11 can divide into 11. Are there any other numbers that can divide into 11? No, they are not. 11 is a prime number. So therefore, we can say 11 is prime. Is 1 a prime number? The only number that can divide into 1 is 1. But the definition for prime number is that it must have 2 different factors as the only factors. 1 only has 1 factor, so 1 is not a prime number. Can you see that you have to know your tables pretty well to recognize prime numbers? Let us play a quick game. Can you spot the prime numbers? What did you say? Here are the prime numbers. How about spotting the prime numbers from these? You only have to think of another number except the number itself that can divide into it. Here are the prime numbers. How many even prime numbers are there? Look at the positive even numbers. 2, 4, 6, 8, 10, 12, and so on. The only prime number here is 2, since 2 is the only number that has 2 different factors, namely 1 and the number 2 itself. All the even numbers has 2 as a factor, so 2 is the only number that is an even prime number. Good. Now that you know what a prime number is, we can do some prime factorization. When we prime factorize a number, then it means we have to break it down into a product of numbers which are all prime. Have you ever seen a factor tree? I'll show you how to draw one. We will start with a number, say 48. We are going to put branches on the tree like this. We start with the lowest prime number, which is 2. Is 2 a factor of 48? Yes. 48 is equals to 2 times 24. So these are our first branches. We put the prime factor in a blue circle every time. Now look at the 2 branches. 2 is a factor of 24. 2 goes into 24 12 times. 12 is 2 times 6. 6 has the factors 2 and 3. 3 is a prime factor. So we have finished our factor tree. We cannot go any further. All the prime numbers are placed in blue circles. Can you see them? What we did here was to prime factorize 48. Now we'll write 48 as a product of prime factors. Collect all the prime numbers in the blue circles. Let's see. 48 can be written as 2 times 2 times 2 times 2 and times 3. So to be 2 times 2 times 2 times 2 times 3. So how many 2's do we have? 1, 2, 3, 4. So it will be 2 to the power of 4 multiplied by 3. This was fun, don't you think? Let us do the next one together. I want you to fill in the empty boxes. Get paper and pen, then you have to write the number as a product of prime numbers. The number is 108. Here is the tree. Right, are you ready? Do you have your pen and paper in hand? Let's prime factorize then. 2 into 108 goes how many times? 2 into 10, we say 5. Into 8, it's 4. 2 into 54, 2 into 5 goes twice. We have a remainder of 1. Into 14 goes 7 times. Now what number now can go into 27? Because 2 cannot now go into 27. The next prime number will be 3. Can 3 go into 27? Yes, it goes into 27. So we put a 3 there. It goes how many times? 9 times. Prime number that can go into 9, again it will be 3. 3 goes how many times into 9? It will be 3 times. Now let's write 108 as a product of its prime numbers. That will be 108 will be equals to 2 times 2 and 3 times 3 times 3, 3 times. So that means 108 will be 2 to the power 2 multiplied by 3 to the power of 3. Every natural number, no matter how large, can be written as a product of prime numbers. So often, calculations with large numbers become much simpler if you write them as powers and products of prime numbers. For example, let's see if you can calculate 108 divided by 27. Remember we said 108 will be the same as 2 to the power of 2 multiplied by 3 to the power of 3. 27 will be the same as 3 to the power of 3. If we apply our laws, our second law says if the bases are the same, we can subtract the exponents. So in this case, we can have 3 to the power 3 minus 3, which will give us 3 to the power of 0. And we know according to one of our definitions, any number to the power of 0, it's 1. So our answer will be 2 to the power of 2, which is equals to 4. Right, let's take a big number and see if we can prime factorize it. Let's take 8,470. Divide 8,470 by 2, we get 4,235. Next prime number will be 5. 5 into 4,235 will give us 847. Then we have 7 into 847. That will give us 121. 121 is divided by 11, which will give us 11. We cannot factorize 11 any further, so those will be our prime factors. Let's summarize what we've done so far. A prime number has only itself and 1 as factors. Any natural number can be written as a product of prime numbers. To use prime factors, it is very useful to know some of these off by heart. You should just know that 2 cubed is 8, 2 to the power 4 is 16. Do you know what 2 to the 5 is? It is 32. What about 2 to the 6? This is 64. Here's your task for this lesson. Learn the answers to the following powers. 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power of 6, 3 to the power 2, 3 to the power 3, 3 to the power 4, 5 to the power 2, and 5 to the power of 3. Well, folks, that was all for today. I'm sure that you'll be able to prime factorize any number. You will need this knowledge in the next lesson. Until then, goodbye.